Hello and welcome to Golden Droplets episode number 27. My name is Ricardo Valls. I am the founder and president of vallsgeoconsultant, and in today's episode we will continue our mini-series of how to represent geochemical results. In our last episode we explained how to use SURFER and Map Viewer to represent heavy mineral concentrates or stream sediments. In today's episode, we will talk about soil sampling and the different maps that you can do with your data. We will concentrate mostly on the graphical part of the presentation, but I will touch a little bit on the preparation of the data too. So here it is, Golden Droplets episode 27. Enjoy. Here is the original data that we're going to be using. It's a soil sampling grid, very simple one. I will not go into all the details of what needs to be done because we covered that on the previous Golden Droplets. But remember, you always will like to check that the coordinates are okay. So you select all the data, go to Insert, Recommended Charts, and you can see that is the correct grid. Okay, let me delete this. So we have gold, silver, copper, lead, zinc, nickel, cobalt, and the rest. The rest is equal to 100 less the sum of all the trace elements. That is why it's almost 100% on every sample. And remember, we use the rest for compositional data analysis. First step we will do is to check the erosional level. And for that, we will use silver and zinc as supra elements and nickel and cobalt as infra. And I remind you the way this works is you have your data here. At the bottom, you have your average and standard deviation, and then you just standardize each value by their mean and the standard deviation. And supra elements will be the sum of silver and zinc. Infra element will be the sum of nickel and cobalt, while erosional level will be the integral part of the sum of silver and zinc divided by the sum of nickel and cobalt. And that's it. That's how we do it. Then we process this data with compositional data analysis. I'm just going to show here the biplot for CLR, which is the one that provides us with the principal component analysis. I just copy here the result and then copy it again, but transform here. And then you just go one by one and you just organize them from the top to the bottom and to see which one have good value. For example, this PC1, it has gold and silver, gold and lead at the top. It could be used, divided, so a coefficient could be lead plus gold divided by cobalt. But when we see the PC2 and the PC3, we can see that the values for gold are much higher or much lower. So I'm going to concentrate on the PC2 and the PC3. So PC2 will be gold divided by lead, and PC3 will be gold divided by silver. We did the LR factors, LR, CLR. We didn't do ILR because we didn't have enough elements, and even the rho factor. And the rho factor is the only one that gave us a potential factor analysis will be silver, gold, and copper. So we create SURFER, the last tab, and where we put the coordinates, the erosional level, supra, infra, PC2, PC3, and factor 1. We really don't need the rest of the element, but we leave it there just in case. We almost finished. Just to make our work easier, I'm going to drag SURFER to the first tab in the file. And remember always to have east and north column in this order. So when we open SURFER, it will read it directly and we don't need to waste time determining which column is the east and which column is the north. Just to refresh your memory, I'm going to show you how we do the varograms. So you click on varogram, new varogram. You select your data. That's the tab that we need. We have picket line, erosional level, that is okay. And this is the varogram that we get. So it's obviously it's not a good fit. So click here. Let's start by cleaning the title. Then we need to plot the variance, and we don't need the subtitle. Then we could go to model and try the auto fit. Okay. And still we have a much better result, but it is obvious that this is a logarithmic function. So I'm going to remove both of them. I'm going to add the nugget effect, and I'm going to add the logarithmic. Click OK, click auto fit, click OK. And then I will use the scale. I think 65 will do. Yeah. And that is a much better fit. And then remember, you use the snipping tool from Windows just to grab this table, copy, and you put it here. Paste. Now, with the varogram open, we need to grid the data. So for that, you go grid data, select the table, tab. The element is there. We're going to be using green. You click on advanced options, get the varogram, click OK, and then here you select the name of the gridding file, which will be erosional level. I already have it done. Okay, so you click here, click save, and you get your gridding data. I did the same varogram for the supra elements and for the infra elements. The first map that we need to do, of course, is the erosional level. So we will create a new tab, and we're going to create home. We're going to create a contour map. Contour map for erosional level. Let's zoom in. Okay. And if we're going to use the normal levels, I'm going to select the fill contours. Rainbow, I like that one. Okay, so we can see that they've contour varied from -280 to 30. But we are only interested in the negative values, the ones that show that the area has been eroded. So to do that, just click on Advanced, edit the levels, and select level, delete, 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 delete. Now this one, we're gonna name it -1, no line, visible, and no color. For this one, we're also gonna eliminate the line, no listed on 9, and we will use this kind of mesh, brown color, and no opacity, no need for labels, and apply. So these are the areas that has been eroded. So we click OK. Now, another very interesting construction that you can do is to try to figure out the orientation of the ore body. And we could do that, at least have an idea, by comparing the maximum values for the supra element with the maximum values for the infra elements. And SURFER gives us a very easy way to do this. And we're going to create a 2-grid vector. And for the first one, we're going to use supra. And for the second one, we're going to use the infra. And then we can put this together. And then to better see this, we're going to reduce the amount of arrows. So we're going to put like, yeah, let's put 6 on both sides. We're going to change the line to an outline arrow. And then the color scaling, we're going to scale it by magnitude. And we use the rainbow. We could use a color scale, but we're not going to put it. But what is clear here is that the ore bodies seems to be dipping in an east-west direction or northeast-southwest direction in general. If we put on top of this map the contour map for the supra, for example, and we're going to only use the highest values for the supra. So we're going to plot only the third quartile. So you go to general information. The third quartile will be 0.3. So you go to levels, edit levels, 0.3. The rest we can delete. And we're going to color this, red. Click no need for label. Click OK. So those are the maximum for the supra. And we're going to do the same thing now, but with the infra. Layer, contour, infra. Click here. Go to general, see which is the third quartile, which will be 0.14. Levels, advanced, edit levels. You should substitute this as 0.14. Okay, delete the rest. I'm going to fill this with a blue color. Need for labels. Okay, and you can see clearly that there are the supra, here is the infra. These are supra, these are infra. So yes, it's a general tendency to go into the northeast to southwest direction. This is, of course, is a general orientation. We cannot base our drilling angles only on this map, but it gives you some idea of how our ore body can be dipping. Next, we will do the diagrams for the other factors that we have, like the PC2, the PC3, and the factor analysis. For each of these diagrams, we will then grid the data and create grid files that we will use to do the next maps. So we will start with a base map. Actually, we don't have a topographic or an image, but we do have the gold values. So I will start by creating a class post. So sampling, SURFER. So we start by defining in general that we need the values for gold, and classes, edit classes. I did this before, that's why already the numbers are here, but basically I define different colors and different size for the values of gold, and we get this map here. I will increase the size of this. Then the next thing I will add will be the erosional level. Okay, so I will add the counter, the erosional level. Click on the erosional level. Remember, we only need the negative values. So we click here to advance, edit levels. Click on the second one, delete, 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 delete. This one we will put the value -1, no line. And no color. This one we will take the line off, and we will substitute this for a mesh, transparent, in brown. Click OK. So this is our base. Okay, so we have the gold distribution and we have the erosional levels. Let us add the next layers. So first the contour map for the PC2, which was gold divided by lead. Okay, and one important thing, the erosional level must be always on top of all the maps. So we come here, go to general, go to information. We need to have the 3 levels of anomaly. So it will be 0.004, 0.5, and 0.6. So we go to levels, advance, edit levels, 0.004, 0.005, 0.006. We don't need the rest. We click on line to select all line as straight lines. Okay. And now we need to change these colors. For the high level, we have these files from the previous Golden Droplet episode. That is the 3rd level. Okay. 2nd level. Okay. And 1st level. And we click apply. And we get a very nice representation of this factor. We clearly have an orientation of southwest to the northeast. Probably some kind of fault here that divided the mineralization. And this part here has been eroded, as well as this part here. So this will be the PC2. Let's add now the PC3 and see how it looks like. So again, contour, Remember always that the erosional level should be on top of everything. And we all can also do these graphics a little bit transparent. So I will put like 80%. This one too, 80%. And then we do the same. We find out what are the levels of anomaly by clicking on general information. It will be 0.04, well, 0.003, 0.004, and 0.005. More or less the same as the other one. So levels, advanced, edit levels, 0.003, 0.004, 0.005, delete the rest. Then we do it the last time. Level 3, okay, level 2, okay, level 1, okay, okay. And let me take this out, and we can see if we get a completely different distribution of the anomalies. Again, it's actually like the reverse of the previous one. So we still have the east-west or northwest-southeast orientation, but it's on the north side of this thing. So the gold divided by silver tend to increase in this direction. Okay, so let's add the last one. Which is the factor at 1. Okay, we define which are the levels of anomaly here. I will leave this open here because the numbers are more difficult to remember. So levels, advanced, edit levels. So the first one will be 1085. The second will be 1140. And the third one will be 1169. And we don't need the rest. The lines, unit levels. It is the third level. Second level. And first level. Okay. And let's again take the erosion level to the top. Make the layer 80%. Here you see that the combination of gold, silver, and has a completely different orientation. It's north-south. Again, we have good spatial correlations in this area here. So SURFER gives you the ability to do different operations with the grids. So we could, for example, create a map, a new map, that will have the result of the multiplication of, for example, grid PC2 and PC3, and that will create a new map. So let's do that. In grids, you go to map. We need to add the grids that we're gonna use. So I'm gonna ask the three of them all together. And my formula in this case will be PC2 and PC3. So it will be B plus C. So I type B plus C, and it's gonna be the output will be PC1 and PC2. I will create a new map, and it will be also a contour map. So click OK. It created the grid. Let me take the map lower, and we go to the same process. General. What are the levels? 008, 009, 0.1. So levels, advanced, edit level, 008, 008, 009, 01. Delete the rest. All lines are straight lines. Level 3. Okay. Level 2. Okay. Level 1. And this will be a much useful map than trying to interpret these ones here. So to finish with this map, we just need to click and drag it just below the contours for erosional level. And here we have our final map. Of course, you need to add to this the scale, the legend, the north arrow, but all of those points I covered in the previous Golden Droplets episode number 26. In this episode, I just wanted to give you an idea of all the potential that SURFER has for the representation of your soil sampling and lithogeochemical samples. With this, I finish Golden Droplet episode number 26. Of course, SURFER has much more possibilities. I just wanted to give you an idea of some of the maps that you can create with SURFER. In our next episode, Golden Droplets 28, I am planning on talking about the use of STRATER to represent your logging results. Until then, I'm wishing you good health, both physically and mentally. Until then, wishing you all good health, both mentally and physically. Have a great day.